In this update, I completed reading section 5 of Gallian and attempted the first 25 problems. There were only 6 proofs. They were mostly calculation problems, and that puts me up to 19.1% of all the problems in Gallian, all 1,688 of them, at 322 problems. Yeah, and that was June 26th. Okay, so then to show the book, this was a section that I was really looking forward to, because when I read in Pinter, about permutations, there were also transpositions, and they scared me. They confused me. So I was looking forward to figuring out if I could learn this section well. I feel like I have. And so the part about transpositions, I'm not really that comfortable with. These are disjoint cycles of order 2, okay? And they're important because of a lemma that says that the identity in the permutation groups is even. Yeah, and this sets up a proof for showing, which is exercise 17, which I'll show, where all the even permutations of the permutation group S sub n are the alternating group A sub n. Yeah, so A sub n is the subgroup of S sub n right here. Yeah, so yeah, the way to do these transpositions, I still need somebody to explain all the variants and how they work. I can play with them. I can easily do the one where you pick up the first number 1 5 1 4 1 3 1 2, or 1 2 1 3 1 6 4 7 4 5. I get that, and I get it when it's done in proofs. I get that. Then the whole business of determining the orders of S7, and then of course after you do S7, you figure out which ones are even and which one are odd, and the ones that are even are also in A7. That sets up a bunch of problems. And then there's also all the combinatorics, which I suck at, of figuring out how many elements there are of that specific order. And there's a factorial term that comes in when there are multiples. See, when there's a 2 and a 2, there's going to be a 2 factorial for that. When there's, let me see, is there another? Yeah, there's a 3 and a 3 right there. That's going to get a 2 factorial in the denominator to cancel out the combinatorics of having 2 that are exactly the same type. That's in the answer book, and that is not in the book. But yeah, other than that, fairly straightforward so far. Yeah, so this is the reading. Nothing eventful there. Of course, as always, I like to work it out myself as I read. Yeah, I like to do it myself, not just let the book give me the answer. These are all things that I worked out myself. Likewise here, seeing how something is changed in the permutation. I don't like these diagrams and the way the book lays it out. I want to see more. I want to see more of this at some other point. Yeah. Yeah, the whole business of disjoint cycles. There's this trick where you're given cycles that are not disjoint, and so the way that I do it is I just break them out into separate permutations and multiply them out, and then figure out what that number really is. Yeah, always even or always odd. And then there's some applications at the end of the section, of section 5, for Rubik's Cube and some check numbers for banknotes. Not sure if I will do all the problems in this section. This may be the first section in which I skip a problem or two. I'm not sure. I'm not sure I want to go for the golden thing of trying every single problem in Gallian. We shall see. Yeah, I worked out several of the numbers in this table that's in the book, just to make sure I understood what I was doing. And the way that I like to do all these is to lay out. I put in the first term. So for example, alpha 2, alpha 4. I'll put alpha 4 in the top, and then leave a row to get the result of alpha 2. Yeah, that's just the way that I do it. and it's helped me a lot. So all the calculations that I did, I believe, were correct when I checked with the answers. Now, I don't understand why in the answer they listed 6 when in the book you're taught by Gallian, hey, you know, that number you don't need to include. It's implicit. Anyways, all the LCMs for the orders, laying out S6, and then laying out which ones are even and odd. I made a few mistakes, but I was like, good enough. I did it. Then laying out whether something is even or odd. You always have to do the breakout into transpositions. That's the trick. So take this thing and break it out. Take this thing, break it out, and then when you check, do you have an odd or an even number? And that's whether it's an even or an odd permutation. Yeah, I felt like I did this proof correct, but the book had a more elegant answer. Yeah, and when I looked at the answer for this proof, I got it right. Then there was no answer in the book for 18, of course, but I believe I did it correctly. Yeah, just lay out all the odds and evens, and the trick is always you're multiplying these permutations, so you're really adding their order, the number of terms to get whether it's odd or even. And of course, for this proof, really, if you lay out that table, that's the answer. That way and that way. And the plus or minus, using plus or minus 1 for even and odd permutations, respectively, does work out. Then here, yeah, I laid out, I completed the if and only if correctly. There are an even number of cycles of even order, and the remaining cycles are of odd order. Yeah, that is correct in the book. So that was pretty steady going with permutations so far, the first 25 problems of section 5.